case for this?
I think I put it on top. All right. Do another problem today, and same as last time, you can go ahead and get started on this. If you want to, if you have access to a printer and want to print out this sheet, I put a copy of it on LMS that you can download and print. And I did put it up last night so that actually quite a bit before last night. I think I put it up right after class yesterday so that people could get it printed out from someplace else if they wanted to. So we shall do this problem. You get started and I'll come along behind and you can check. You get started and I'll come along after a little bit and start writing down answers so you can check and see how you did. If you did it wrong, fix it. And if you did it right, how do I say this? Did it wrong, fix it. If you didn't do it, do it. And if you just copy everything down, make sure it's all right, you can get full credit for this PFG. We will be doing one more like this, in this manner, I mean, on next week, and then they will be do it all by yourself. So this is a good time to ask questions if you have them. And this is a good time to really be trying to get it right and not just waiting for me so that you can copy it down. So if you haven't already, go ahead and get started. I will wait a minute or so and then I'll start up behind you. While you're working on that, I will mention that there is a question on the quiz that I will have to fix the answer for and change your grade for if you've already taken the quiz, or take it before I fix it. So don't worry about that. We'll get it all taken care of. That's interesting. All right. So there's an interesting oxidation rule right here. Remember, we have to go with the strongest rule. And oxygen is almost always -2. And there are, stupid. And there are 2 of them. And this has to equal 0, which means chlorine has to be +4, not its usual -1. Oxygen's almost always -2. Hydrogen's +1 with nonmetals, and that does add up to -1. Here, oxygen is -2, and there are 3 of them, and it has to equal -1. So chlorine would have to be, come back, 2, come back. 5, chlorine would have to be +5. And here it's -1. Because they're the same as their charge. Now we have a really, really, really interesting case here. And this is going to give us a little bit of, we're going to have to pay very close attention to what we're doing, because chlorine goes from 4 to 5. Chlorine goes from +4 to +5. That's an increase. So that chlorine is oxidized. And chlorine goes from +4 to -1 on this chlorine. So chlorine is also reduced. This chlorine is oxidized, and this chlorine is reduced. So we still do it the same way. There's going to be one kind of slightly different thing at the end. But we can keep going just like normal. So now, if you haven't, you should if you have not done it yet, you should write the half reactions. Remember, the half reactions need symbol, subscript, and oxidation number. We're going to start with this chlorine, chlorine +4, for both half reactions, but we're going to end with different things for the right side of the half reaction. So Cl +4 becomes Cl +5. +5. And then Cl +4 becomes Cl -1. Whoops, where'd the L go? And none of them have a subscript, so it's 1, 1, 1, 1, 1, 1, 1, 1. So they're already balanced. Okay, let's see. We did this one. We did this one. Balance the elements. They're already balanced. Now the charges, remember, it's coefficient times subscript times oxidation number. So I'm just going to do it. I'm not going to talk it. right, if you have any questions, raise your hand and ask. I'll give you a minute to balance the electrons and see if you can get that right. These come multiple of 5, and 1 is 5. So 5 times 1 is 5, and 5 times 1 is 5, and 5 times 1 is 5. Okay, cancel the electrons and add the 2 half reactions. Whoops. In my head, I said 5, and on the paper, I wrote C, or the screen, I wrote C. So, is there anything in the original equation? What did we have in the original equation? We had some O's and some H's, so yes, there is. So, since I can cut and paste, too bad you can't cut and paste on paper. I mean, I guess you could if you wanted to get out the literal scissors and paste, but you know, that would be kind of a mess. So I will rewrite my original equation or cut and paste it. Highlighting. Give myself some extra room for all those coefficients I need to write. Right, here is where we run into the one little oddity of using the same thing to be oxidized and reduced. So if you're ahead of me or if you're behind me or whatever, now would be a good time to be looking. Cl plus 4, Cl plus 4. They both came from here. That means I have to write 5 plus 1, this 5 and this understood 1, which means that this is 6. And that's the only difference that this will make for us. And I'm going to erase that because I'm afraid it might get too distracting later. Let's see, the plus 5 came from right here. And this is an understood 1, so it stays an understood 1. And remember, we don't have to add them because these were two different things in the original equation. All right, how are we doing on this? Any questions? Well, I'll give you a minute to try and see if you can get H done. And then I'll do it and you can check and see how you did. All right, so there's nothing extra other than oxygen and hydrogen, so we don't have to do this one. Which brings us to balancing the charges. I got this in since last time. It's coefficient times oxidation number. So 6 times 0 is 0. 1 times -1 is -1. So the left side adds up to -1. 5 times -1 is -5. Understood 1 times -1 is -1. So the right side adds up to -6. So I'm going to have to add 5 hydrogens. To this side to make these two equal each other. So plus 5H plus. Now, done. Now see if you can balance the hydrogen and the oxygen by adding water molecules. We have always added water. I think every time we've done it so far, the water has gone on the right, but we're going to need more hydrogens on the left this side. So the water is going to go on the left this side. Left side this time. So go ahead and see if you can get that done. And I'll give you a minute, and then we'll come back and do it. All right, so let's see. We got 5 hydrogens on the left and 1 hydrogen on the, whoops, 5 hydrogens on the right and 1 hydrogen on the left. So we're going to need, let's see, 4 more. So the 4, so 1 hydrogen, I need 4 more to make 5. So I'm adding water. So 2H2O would balance the hydrogen. 2 times 2 is 4, plus 1 is 5, and 5. Now I check the oxygens. And this, we got to pay attention on this one. We've got 2 times 1 is 2 oxygens right here. 6 times 2 is 12 oxygens right there. And then understood 1 times understood 1 is 1 more oxygen for a total of 15 oxygens. On this side, 5 times 3, oh, look at that. 3 times 5 is 15 oxygens. So we balance the hydrogens, oxygens balance, must be right. So if you have questions, ask away. If you don't have questions, turn it in sometime before 4 o'clock. And the quiz is, I think, fixed. So you should be able to take that now without any problem. I think, I hope. And other than that, have a good weekend. Enjoy your Easter. So, any questions? Noah, did you have a question?
Yeah. How do you do, like, where do you get the numbers for step I? I'm still confused on that part.
Coefficient times oxidation number. So 6
Okay.
times 0 is 0. Coefficient understood 1 times oxidation minus 1 makes minus 1. 5 times minus 1 makes minus 5. And understood 1 times minus 1 makes minus 1.
All right. That makes sense.
Any other questions? All right, there are 7 of you left. Are any of you going to be asking anything, or should I close the session?